Alright, ladies and gentlemen, this is Mark Anderson for Keller Community College, and today's video is going to talk about work problems. These are problems that try to figure out how long it would take two things or people or more to finish a job working together. Now, work problems always add up to one job. So that's the one commonality in all of the work problems, is that there's one or two people or three people that add up to one job. It's probably best to start off talking about one person. Let's say one person finished a job at a certain rate. So let's say it took you 30 minutes to clean your room. 30 minutes would be your rate. The time it would take you to clean your room would be based on your rate. So if it was just you cleaning your room, then it would be 30 minutes of time for your 30-minute rate to finish the one job, or 30 divided by 30 is 1. But you can have someone else help you, and let's say their rate was faster or slower than you. Combined, it would take you less time than your 30-minute rate to finish your project. The time for both of you to finish the project would be the same numerator, even though your denominators might be different. So you might have a denominator of 30, and your friend might have a denominator of 15, meaning it would take them 15 minutes to finish cleaning your room. But working together would take less than 15 minutes total, so your numerators would be smaller than that. To find these answers is going to basically use the the technique that we learned back in a previous section about solving for x with rationals. But learning how to set up these problems is really where most of the difficulty comes in. Let's begin with the printer problem. One printer can print paychecks for the employees of a company in 60 minutes. That means that that machine has a rate of 60 minutes. That machine working by itself would take 60 minutes to finish this job, or 60 over 60. But there is a second machine that can print the checks in 90 minutes. So this would be a second printer, and its rate is 90. Our job is to find out x, and to do so would then tell us how long it would take for both machines working together to finish the job. Please keep in mind that both machines would actually finish in less than 60 minutes, because if this machine working alone did it in 60, then two machines working together, no matter how slow it is going to get the answer in less than 60. So what we would do in this equation is we would find a common denominator and multiply by that denominator. The common denominator between 90 and 60 is 180, because both of those numbers can be made into 180. So I'm going to multiply both sides by 180, and that would essentially multiply each of these numerators by 180. So 180 divided by 60 is going to give me an answer of 2x. So I can use simplification rules to give me that answer. And also 180 divided by, 3x, not 2x. Sorry about that. And then 180 divided by 90, this is where the 2x is. So 3x plus 2x equals 180 times 1, which is 180. The 3x and the 2x make a total of 5x equals 180. Dividing both sides by 5, x is equal to 36, which means that the first printer took 36 minutes and the second printer took 36 minutes. So if you want to check your answer, you can go 36 over 60 plus 36 over 90, and that will equal 1 if you do your common denominator and follow through on the problem. 36 sixtieths plus 36 90ths adds up to 1. For problem number 2, we're looking at another problem with a little bit trickier wording here. It says a new printer can print checks 3 times faster than the old printer. So here we have a new and old printer, and they're both going to work together to make one job. The older printer can print the checks in 48 minutes. So that means the older printer is 48 for its rate, and the time again to finish the job is x. How long would it take to print the checks with both printers operating? Now we need the equation for the new printer. The x in the numerator is going to be how long it took to finish that job. It's the same x as the one over here, but it says the new printer can print checks 3 times faster than the old printer. Now one of the common mistakes is people multiply the 48 by 3, but that would make the printer slower. So we're going to divide the 48 by 3, which makes 16, so this new printer is 3 times faster than the old printer. The new printer has a shorter runtime than the old printer. Working together, these two printers should make an answer that is less than 16, because working by itself, the new printer would get this all the way done in 16 minutes. So what I'm about to do is multiply everything by the common denominator. In fact, the common denominator of 16 and 48 is 48. So if we multiply everything by 48, so 48 times this, and 48 times this, and 48 times this, we have lots of simplification to do. We have 3x plus, with these simplify out here, and I say 3x because this would divide out and make 3, so 3 times x. This divides to make 1, so this is 1x, and 48 times 1 is 48. So now we have 4x equals 48. We divide both sides by 4. X is equal to 12. So we have our answer of 12 minutes for the printing of these checks, which makes sense because the one printer working alone would take 16. The old printer chugging along would cut 4 minutes off of our time. All right, for our final three problems here, we have a gardener of a gardening team who can mow and clean up a lawn in 12 hours. So we know this person's rate right here, and then what we're going to do is set this equal to 1. Now it says, with both members of the team working, so there's another teammate here, the job can be done in 8 hours. How long would it take the second member of the team working alone to do the job? Well, right here, it changes the scope of the equation because in this case it tells you that the job can be done in 8 hours. This means that the x, or the total work time, is now 8, and we're trying to figure out the denominator of this new fraction over here. So what's going to happen in this problem is we're going to have to get rid of these denominators by multiplying by the common denominator. The common denominator of 12 and x is 12x. So if I multiply each of these by 12x, I will get some simplification, multiplying each by 12x, and we'll see the denominators go away. The 12 simplify here and leaves me with 8x. Here the x's simplify and leaves me with a pretty big number, 96, because 8 times 12 is 96. Over here this is 12x. Now what I'm about to do is move the 8x to the right because I want to see what that gives me, trying to get the x's all by themselves, and this gives me 96 is equal to 4x. Dividing both sides by 4, my x is equal to 24. So it looks like my coworker here, that should look more like a 4 rather than the 9. Okay, so it looks like my coworker is going to take 24 hours to finish the job, but working together it should take less than 12, so it took us 8 hours to finish the job. And also you can check your answer by going 8/12 plus 8/24, and that equals 1. Now this is a situation where we have 3 printers. 3 printers can print out a task in 12 minutes, 18 minutes, and 36 minutes respectively. How long would it take to complete the task of all 3 computers working together? Well, with these computers, we are going to have 3 different fractions, and each computer is going to have its own working speed. 12 minutes, 18 minutes, and 36 minutes. Once we get done working together, all 3 computers should be done in less than 12 minutes, because these slower computers are still going to help push this computer along. So what we will do is try to find the common denominator of 12, 18, and 36, which so happens to be 36. So if I multiply everything by 36, including the other side, because as a rule in mathematics and algebra, if you do something to one side of the equation, you have to do it to the other. And that, my friends, is going to give us on this one side 36, but all these are going to simplify to something small. 36 divided by 12 gives me 3, so this becomes 3x. 36 divided by 18 gives me 2, so that gives me 2x. And 36 divided by 36 just gives me 1, which gives me the 1x. So 3x plus 2x plus 1x is a total of 6x, equals 36. Divide both sides by 6, x is equal to 6. So it will take all 3 computers working together 6 minutes to finish the process, which is much faster than the first computer, but all these slower computers will help take care of the problem. And finally, we're going to look at an inlet pipe fill an empty water tank, and let me put here empty because that could be a clarification that some of you might need in the problem. An inlet pipe can fill an empty water tank in 48 minutes. So this pipe is x over 48. The outlet pipe can empty the tank in 16 minutes. So this is going to be the flow of that pipe. How long does it take to empty a full tank if both pipes are open? So we are going to assume just some basic principle that you can fill a tank in 48. It basically is going to empty the tank in the same way. We're not going to push or force water in either direction here, so we're going to assume that this is going to stay the same. So now what we're going to do is find the number that 16 and 48 both make. And like in the problem above, the common denominator of 48 and 16 is 48. So here's 48 multiplied by everything. 48, 48, 48. And we have some simplification here. So x, we have this simplify right there, so it gives me 3x is equal to 48. We add the two numbers together, which makes a total of 4x is equal to 48. If we divide both sides by 4, x is equal to 12. So even though the big pipe that empties the pool could take 16 minutes, if that small intake pipe was also opened up to drain out the water, it would save 4 minutes of time by doing so. Well, thank you for watching today, and I appreciate the time. Again, send me questions in KCC email if you've got questions or comments. Thanks.